Okay, our next equation that we're going to solve, number 2, is 3x plus 4 equals 10. Remember that you are writing on your paper, each student is writing on their own paper, that you use the manipulatives together in pairs. Okay, you probably, based on the last problem, you probably already have grabbed your 3 cups. If not, go ahead and grab your 3 cups. And what do the cups represent? They represent x. What represents the plus 4? 4 positive yellow counters. Plus 4 and positive 4, you can think of those as the same thing. Now, this expression, which is 10, is represented by 10 yellow counters. Now be aware that the manipulatives can be very noisy, so you really want to try to remind each other to stay on task and make sure that everybody is able to follow along with the video and your noise level is not disturbing anyone. Some of you guys are wanting to guess and check, and that's great, but keep in mind, if you'll look on the whiteboard, the did you know, by the end of this year, you will solve equations that are as large as 9x minus 15 minus 2x plus 4 equals negative 22 plus x plus 3 plus 2x. And that's incredibly complicated, and guessing and checking would be very difficult. So the manipulatives are to help you understand, not just remember what to do, but to really understand how to use inverse operations to solve equations. Some of you guys are familiar with it. Your pre-test scores, pre-test, indicates that you are familiar with equations, but you just really haven't quite mastered the inverse operations. Most students are wanting to guess and check, and it worked out okay for a few equations, but then the equations got more complicated, and we're nowhere near, right now, these equations right here, nowhere near as complicated as they're going to be by the end of the year. So let the manipulatives do what they're supposed to do, which is really help you grasp how to use inverse operations. Okay, just like in the previous problem, we want to isolate the cups. So in order to remove these 4 positives, we're going to add 4 negatives. And whatever we do here, we are also going to have to do over here. Please remember to take turns using the manipulatives. Possibly let the person that's sitting on the left work this side, and the person that's sitting on the right deal with these counters. But remember that each student is writing on their own paper what we're doing here. Well, I'm going to write down what we just did by, we added 4 negatives here, and we added 4 negatives here. Well, a negative 4 and minus 4 are the same thing. Now we need to simplify. We've got all these red and yellow counters mixed together here in this expression. We have all these red and yellow counters mixed here in this expression. So we're going to simplify by removing all the zeros. Remember that 1 negative and 1 positive cancel and make 0. I'm going to remove all 6 of those at the same time. They're all values of 0. Same thing here. So now I have 3 cups and 6 yellow counters. And what that looks like on paper, since the cups represent x, I have 3x. And obviously we can see that a +4 and a -4 cancel. And this expression over here, +10 minus 4 is 6. And we can see it represented by the 6 yellow counters. Now the next thing we need to do, the next thing we need to do is divide these 3 cups into 3 separate groups so that I can focus on just one group. I'm going to take the 6 counters and evenly divide the 6 counters into the 3 cups. I don't know why this counter shows up in front of the cup and the other counters go behind the cup. I don't know why it does that. And when you're dropping your counters into your cup, they may flip over and you may see the red side. That's okay. You just need to understand that they were in fact yellow to begin with. And when you're dropping your counters into your cups, they can be incredibly loud. So you just want to be aware of the noise that you're creating and try to make sure that you're not disturbing anyone else, and try to make sure that your group and all your group members are staying on task as well, and that the manipulatives are not necessarily a toy to distract you, but to actually help you grasp a math concept. Now we're going to show that we divided the cups into 3 separate groups, and we divided the counters into 3 separate groups. And if we look at just one cup, which is x, it has 2 counters inside of it. Therefore, my solution to the equation 3x plus 4 equals 10, my solution is 2, which basically means my answer. So the value of my variable is 2. And we're going to go to a blank screen, and we're going to check by using substitution. I think that x has a value of 2, so I'm going to go to my blank screen, take my original equation, 3x plus 4 equals 10, and I ended up with all my work on the previous slide. My work indicated that x had a value of 2. So I'm going to check and see if 2 is in fact a solution of this equation. You may not have given yourself enough room in your little box. That's okay. Next time you will. 3 times 2. What is this called when I remove a variable and stick in a number? Substitution. Remember to use order of operations. This is multiplication, and this is addition. According to PEMDAS, I multiply first. Most students want to stop here because this is what you did in elementary school. You were given a problem, 6 plus 4, and then your answer is 10. Well, that's great, but the reason why your answer is 10 is because when you simplify the expression 6 plus 4,